Whoa, is that a... Hold on, let me get my trusty Pokédex and check. Oh man, what's a Mew doing in my kitchen? Haven't we all asked ourselves how we could better identify all the Pokémon outside? No? Well, too bad, because I spent the last weeks making a real-life Pokédex you can actually carry around. To get there, we are going to use deep learning to train an image classifier, and like any machine learning project, we have to start by gathering data. And like the big guys, I'm just gonna steal that data from the internet. Now, getting a lot of pictures for each Pokémon is going to be quite difficult, because there are like over 1,000 of them these days. One source that has pictures for each of them though is Pokémon Showdown, and luckily it's not too difficult to just yoink everything they have to offer. I already knew they had a more or less public media database, and I was able to locate it quickly using the browser developer tools. Looking at the site, it seems to contain every single sprite of Pokémon ever used in any game, including some funny meme sprites for April Fool's Day. Of course, as a programmer, I'm not gonna open each image and click download. Luckily, manual web scraping has become super simple these days with the help of ChatGPT, and you can basically just give it the relevant HTML and tell it what you want to scrape. Well, not quite, but it's so much simpler than doing that process manually. After fiddling around with it for a bit, I ended up with a piece of code that recursively downloads all images from the website. Now, I have the entire Showdown sprite database on my local PC and ready to use for training. I also found that there are many GIFs on Showdown, and I extracted each frame as its own image. That's great and all, but the images are mostly homogeneous in their art style. I'd like the model to be able to detect any kind of Pokémon image, not just sprites. So I started another scraping session and downloaded all available Pokémon cards from the trading card game. These images are much more diverse and will help the model become robust towards a greater variety of Pokémon. Combining the datasets, I have around 700,000 images, split into 1,025 classes. To increase the variety of the data even more, I added a whole bunch of augmentations. For example, flipping, rotating, color jitter, random dropout, and so on. These are automatically applied when the files are loaded, so the model never sees the same image twice. This not only makes the model more reliable, but it also helps to combat overfitting. Now, I'm going to use PyTorch to train a state-of-the-art vision transformer model from the Transformers library. Wait, hold on. I'm not going to run this on my RTX 4080, but on a portable device. That's not going to work. Instead, we're going to train a very lightweight mobile net architecture. It should still give acceptable results and be much more compute efficient. We are now ready to start the training. On the right side, you see some images that are not part of the training dataset, and when they are detected correctly, we know that we are on the right path. The left side shows quantitative metrics to track actual model performance. Let's see how the training goes. After one epoch, we already have over 90% validation accuracy, which is amazing considering that we have over 1,000 classes to predict. And while the model is training to convergence, I wanted to thank you guys so much for the support. We went from around 1,000 subscribers to almost 8,000. If you liked the video until now, feel free to join the club. We end up with a validation accuracy of 97%, which is pretty good considering the model size and data amount. You should take this number with a grain of salt though, because the validation data is quite similar to the training data. The mystery dungeon images are an alright indicator of the true performance, but most of what I'm trying to predict is way outside of the training distribution, so the accuracy could be much worse in the real world. I quickly wrote an inference app where I can drop pictures and the model tells me the predicted Pokémon. Here I'm testing it with questionable images from the internet. It seems to work quite decently on costumes, but I also added some April Fool's Day sprites from Pokémon Showdown. And I mean, that does kinda look like an Eevee. But that is not what you guys are here for. You want to see a real Pokédex, so let's build one. And like any good computer scientist, I have a box full of electronics garbage just waiting to be used. I actually already own every single thing that we need. A Raspberry Pi, a display that I disassembled from an old laptop, a fitting controller board, a €5 webcam, and all the peripherals needed for control. And here you have a recreation of me setting up Linux, the Python environment, PyTorch and the camera on this slow as hell Pi from 6 years ago, twice, because the first time PyTorch wasn't supported by the OS I picked. That was fun. With that sorted out, it's now time to start putting everything together. It looks like the display got damaged a bit while in storage, but that shall not deter me from using it anyway. Now, of course we want our Pokédex to be portable, so we need to use a power bank instead of getting energy from a wall outlet. We also need a suitable travel case for all the accessories, and I found one that is quite fitting for the project. Let's just put all of this stuff in there, right where it belongs. I also added some convenient shoulder straps to carry it anywhere. The project is almost functional now, but it's looking a bit rough around the edges, so let's make it more aesthetic. I did that by giving it a Pokédex makeover using my favorite program, Microsoft Paint. And here's the final Pokédex. You can buy it now for only $5,999.99, but you will get 10% off if you're a subscriber, and you definitely don't want to miss out on that deal. Let's take it for a test run. Though, if I go outside with it, people are gonna call the police, so I'll stick to scanning my wife's plushies. There's a bit of delay in the camera feed when using the power bank, but other than that, it seems to be working perfectly. I also tried it on this epic shiny Mega Gengar cosplay, but for some reason it didn't register. But aside from that, it's working better than I expected, and it was also pretty fun to make. Right before we end the video, I wanted to give a shout out to Elliot Transom for guessing the topic of this video based on the number 1025 alone, and also to Tilt Gore, who generously made the first donation to the channel. Thank you so much, I really appreciate the support. Anyway, that's it for now. I have some really cool project ideas coming up and you definitely don't want to miss them, so see you in the next one.